All right, let's go about doing the next lesson, which is scientific notation. SCE. Scientific notation. Right, and the objective is to write any rational number in scientific notation. Right? If you already know how to do this, then you don't need to watch this video. If you don't, then pay attention to what we're going to do. Whenever you're writing an answer, sometimes the answer is very large or sometimes the answer is very small. And because of that, you would need to start writing it in a different form so that it looks like a significant kind of number. What we do is we write it in scientific notation. So let me just write a little bit of a note here for you. So scientific notation is a way for expressing very large and small numbers in a more compact form, and it is used in science and engineering to make calculations easier. Right? It is used to write numbers as a product of a number between 1 and 10 and a power of 10. Right? Let me just put this on the next line, 10. Good. So that is what scientific notation is. It makes your calculation easier. So if you're going into science, you should learn this properly so that you'd be able to write your numbers in scientific notation. First things first, let me just give you a general form, right? So the general form of something in scientific notation tends to fall in something like this: n times 10 to the n power. Actually, I should put r here, right? Let me just put r here instead. Right, so it suggests it's belonging to the set of real numbers, right? So r here would be greater than, equal to 1, or less than 10. So if we want an example of this, you know what, let me just put this here in a different color. I'll put it in yellow, and then I will write the example in pink like I usually do. So example, let's say for instance you have 759,000. Now this is a large number, but it's not so large that you may want to write it in scientific notation, but later on you might. So let me just show you how to do this. So this is written in a compact form as 7.59 times 10 to the power of 5. Or let's say for instance you have something that's small, 0.0034. Then this can be written as 3.40 times 10 to the negative 3 power. All right. So when you're doing scientific notation, you just have to figure out which direction you're going to be moving the decimal point, and then multiply it by a power of 10 to something. All right. Multiply it by 10 to the power of something, sorry. Right. So let me write something here for you to have a set of steps then to write a number in scientific notation. So let me see. So we're going to talk about writing a number in scientific notation. Right, I'll put that in yellow as well. Right, and then let me start here. So the first thing you want to do is you want to determine the current position of the decimal point in the number. All right, the next thing you want to do, and you know what, let me just put a dot after this, dot. Okay. All right. So next thing you want to do is you want to move the decimal point to create a new number between 1 and 0. Well, not 1 and 0, 1 and 10, sorry. And then count the number of places you move the decimal point, right? So you move it until it is the number is between 1 and 10, and you just simply count how much places you move that decimal point. The third step is you're going to determine the exponent by one of the following. Let me just put a dash here. So if you move the decimal point to the to the left, the exponent n is positive. And then if you moved the decimal point to the right, then the exponent is n is negative. Alright, so to determine the exponent, all you have to do is figure out where you're moving the decimal point to. If you're moving it to the left or you're moving it to the right. Last step is that you combine the new number with the power of 10, actually. Yeah. Okay. Combine the new number with the power of 10. From there, you'd be able to get scientific notation. Okay? So I'm going to go through each step for the example that I showed you earlier. So let me just start off with the example that I have. The example that we had earlier was 7591230. So I'm going to do each of the steps as we go along. Okay? So the first step is the decimal to identify the location. As we see here, determine the current position of the decimal point in the number. Okay? So the decimal point is at the end. All right, what does that mean? It's like 75900 dot. Okay. Then the next part is to move the decimal until we get something between 1 and 10. So I'm going to have to move it to the left, and I'm going to see that move the decimal 4 places to the left. You know what, let me just put this in a different color so that you can identify it as we go along. I'll put it in orange. All right, so now let's see, orange, and the new number will be 7.59123. So we move the decimal, not 4 places, 5 places. All right, so we move the decimal point 5 places. So 1, 2, 3, 4, 5. Good, so 5 places. So now we have 7.59. The next thing we're required to do after we move the decimal point is determine the exponent. Now, since we move it to the left, the exponent is supposed to be positive, right? So since the decimal point moved to the left, the exponent is, we have on the page, positive. All right, and since the exponent is positive, we're going to have a positive 5 as the exponent. Okay, final part, we combine everything together, and the scientific notation is 7.59. I'm just getting rid of all of these excess additional zeros. 7.59 times 10 to the fifth power. All right. Now, from there, what we're going to do is we're going to do another example, but I'm not going to go through the steps in detail as I did before. Let's do another example. So example, let's say I have to write 0.00456 in scientific notation. Another way you can ask for standard form. Right? Scientific notation or standard form, same thing. Right? Both of them mean the exact same thing. So writing the solution to this, we are having 0.04, sorry, another zero here, 0.00456. We're counting 1, 2, 3 decimal places to the right, so that means it's negative, and therefore this here would be equivalent to 4.56 after the decimal point is moved, times 10 to the power of negative 3. And that's your answer. This is fairly straightforward and it's not something difficult to do. So that's it. As long as you practice that, you have no issues. You will get more practice of this when you start working on the multiple choice in the exercise sheet that we have. All right. If it is that you don't know where to get the exercise sheet, let me give you a QR for the Google Classroom. All right, so this is a link for the Google QR, the Google link, Google Classroom. Right, that's the link for the Google Classroom. So you just look up Google Classroom and then this is the code that you're going to be using. If it is you want a QR, 1 second. Okay, so this is the QR code for the Google Classroom. If you can't use this link and you don't know how to use the code at the end, which is this little piece on the end here, let me just write it to you. So this little piece on the end here is the code for the classroom. If you don't know how to use that code to get into the Google Classroom, just simply scan the QR. Now you're going to find the notes there and you're going to find the exercise sheet that is going to be done at the end of this section. Once you get a lecture done, just look at the question paper, see if you can solve anything. At the end of the section, I will do a live session where I will solve the problems and answer any questions that you might have.